Since everybody's still here, and nobody hurt my feelings. Well, good. So today, we want to talk about hybrid analysis mapping, which is some research that we did at Denham Group, some research we did in conjunction with the U.S. Department of Homeland Security, and we'll talk about some of the benefits that came out of that research that we actually didn't expect when we set out on it. But we've put together some, what I think are some interesting ways to make development tools do security better, and for security tools to be made better using some benefit from the development tools. Here we go. That's a picture of me, in case you were unsure of what I look like. I'm not entirely sure why that gets included every time, but that's fine. I'm Dan Cornell. I'm the CTO and founder of Denham Group, and my background is as a developer. Started out initially doing a lot of early server-side Java stuff. In the early 2000s, I did some early ASP.NET stuff. But what I've really spent the last 8 or 9 years of my career doing is looking at how developers and how folks developing software impact the security of their organizations. And so asking, how does development impact the security posture of an organization, and how do you get developers to build more secure software on a more repeatable basis? And so that colors a lot of what I talk about, or how I describe this, I think. But again, I come at this from a development background, coming into security. Again, been involved in OWASP for a long time. I help run the OWASP San Antonio chapter, and so on and so forth. And so what I want to start out talking about is looking at what security teams typically want, what their goals are, and to contrast that with what development teams want, and to look at the types of tools that each of those organizations tend to use. And that'll set the stage then to look, we'll talk through this research that we did on what we call hybrid analysis mapping, which is looking at how, the initial research was looking to see if we have results from a static analysis tool, code review tool, and if we have results from a dynamic tool, a web scanning tool, can we merge those together? Essentially a data management problem. Is there a way that I can take these two different data sources and stitch them together so that people don't have to do that manually? And then we'll look at, I'll talk through some of the internals of what we built and the outgrowth of that, some additional tools that we were able to build based on that technology that are all available for free, open source, downloaded from GitHub, and we'll have links and pointers to all that stuff. And I'll go through some demonstrations of the tools that we built and how those can help solve certain problems that we see development teams facing, as well as security teams facing. And we'll have, I think, some time for questions at the end, but this is a good-sized group. If you have questions along the way, please feel free just to raise your hand or wave your hand at me and stop me, and I'll address those. Any questions so far? All right. Everybody's still committed to this talk and not going to the OpenSAM talk? That's good. We're even getting new folks. This is great. All right. And so, again, just career-wise, I've had the opportunity to work both on the development side as well as on the security side, and that's given me the ability to see kind of how these different teams work. And development and security teams certainly have different goals. They get rewarded, they get compensated and rewarded in different ways, and that leads to different behaviors. And they also use very different tool sets, and that's one of the big challenges that I've seen as security organizations try to go and work with development teams. This is starting to change, but a lot of the more traditional security folks, the security practitioners, don't have a strong background in development. Again, at OWASP here, I think we see a lot of really good and healthy crossover, and we're seeing more of that in the industry. But if you look at the installed base, if you will, of developers and the security teams that are trying to work with them, there's not a tremendous amount of crossover. In fact, it's interesting talking at like ISSA events. You'll ask, hey, how many of you folks, have a programming background? And lots of people raise their hand, and you say, well, how many of you have a programming background that's not in Fortran or COBOL, right? And all the hands go down, right? And so, so that's a challenge, because you don't see a lot of, again, more traditional security folks that have a strong background in modern web development, where they understand, Java, they understand .NET, they're used to building, modern web applications. The challenge is, and this is one of the reasons why I think application or software security is so hard, but also why I think it's a really interesting area in which to work, is like these groups have to work together. You know, the development team, if left to their own devices, is probably not going to create software with an acceptable level of security that's going to manage or control an organization's risk. But the security team doesn't have the ability to solve the problem themselves. And certainly not in the way that they, security teams typically have much more control over their environment to handle more infrastructure or network issues. And so these groups have to learn to work together. And the organizations that we've seen that have made the most progress for software security, these groups have learned to work together. And one of the things that we found to be an indicator of success is the ability of the security team to start to get their minds wrapped around how developers work, which involves understanding how developers use different tools. From a development standpoint, right, when I was doing development, and our folks that do development, it's features, functions, timeline, right? I have X number of use cases or user stories, right? I have a certain number of team members, I have a certain amount of time, I have a budget for pizza and Jolt Cola, which they apparently no longer sell, so Mountain Dew, whatever the kids drink these days, Red Bull, Monster Energy drink, I don't know. But we've got these resources, we've got this stuff to get done, and we just need to finish it, right? And developers don't get rewarded for writing super secure code, typically, much as they don't get rewarded for using every pattern in the Gang of Four design patterns book, right? Although for some reason developers are more than willing to take extra time to use all the design patterns in the Gang of Four pattern book, but are less interested in security. I don't know why. But developers don't get rewarded for writing pretty code, right? They don't get rewarded for writing fast code unless that's a critical business thing. They get rewarded for writing code that has a suitably low number of bugs and getting it done on time and by whatever means necessary. And if you look at how developers manage their workload, typically most development teams are using some sort of change management tool, often a bug tracking, defect tracking system, right? A lot of folks using Jira, Bugzilla, bigger organizations, HP Quality Center, stuff like that. That is where the to-do list for a lot of development teams live. That's how they get work. That's how they manage their workload. And if you look at where they spend the majority of their day, it's in their IDE, it's in their integrated development environment. That's their window to the world, that's where work gets done. And so there's challenges when you see security teams come around and say, for security purposes, right, you're doing all your work over here in your defect tracking system, that's how you're tracking all your work. But instead for security, which is a magical, separate, special thing, you need to do your work off of this 300-page PDF that I've printed out and put sticky notes on the stuff that I think is important, right, from the scanner, right? Or you need to log into this other system to manage your security workload as opposed to using your defect tracking system. And so that creates friction, right, and in a lot of cases gives developers an excuse to say, I was going to fix security bugs, but it's too hard, right? Or it was easier for me to work on this other stuff as opposed to fixing these security bugs. If you look at security groups, it's what's our policy, right? What are our standards that we use to try to meet that policy? How are we managing risk? And the goal is to keep the world safe, right? Which is a much more amorphous goal than most development teams have. And what we've seen is a lot of network and infrastructure tools and paradigms are kind of getting crammed down on the development teams, right? And so, folks say, well, for network security, we use network scanners, right? And that solved the network security problem. So why, if we've got a network scanner to find problems in networks, why don't we make an application scanner that's going to do the same thing for an application? Or we used firewalls to solve the problem of hackers and keep them on the outside. In the network and infrastructure world, let's make an application firewall that's going to perform a comparable function over here. And so I think we've seen a lot of the dubiously successful paradigms from network and infrastructure security applied in an even more dubious and less successful way in the application in the application space. The problems with security tools, if you're a security person, again, if you're coming into or if you're coming into software security from a background as a sysadmin or network or infrastructure person, if you don't have a strong software development background, it can be really challenging to use static analysis tools, right? And certainly it would be challenging to use them, and it's even more challenging to use the results that come out of those static analysis tools, right? It's really tough to get a clean or a good static analysis run if you don't know how to run a software build. If you've never used Make or Ant or Maven and don't understand that process of how software dependencies get to put together and libraries get to put together, it's going to be really challenging for that person to be successful running a static analysis tool and dealing with the results, right? And that's another challenge in a lot of cases with static analysis tools is the plethora of results that you see coming out of them that you've got to be able to look and say, okay, well, this is the important stuff, this is the stuff that I want to check next, and this is the stuff I'm going to get to when I have time. Again, in the absence of a strong understanding of how applications are constructed, how applications get built, and how the code works as traffic flows through it, it's really challenging to be able to interpret those results successfully. Dynamic scanning tools have their own challenges as well. They've got to be properly configured to get good coverage. And I tell this story all the time. We were working with a big financial organization, and they said, "Hey, we ran this fancy commercial scanner on our application, big 500-page Java-based web application, and we found no vulnerabilities. Right? Security is solved in our organization because we got a clean scan." Took a look at the scan results and said, "Well, you scanned the home page and the login page." You didn't train it to log in, so it didn't actually check the other 498 pages in the application. And I suspect if we take a closer look at those, then there might be a couple problems that you need to be concerned with. So don't break your arm patting yourself on the back just yet. We've still got more work to do. And that's a challenge with the scanners. Even if you've got them successfully configured to log in, scanners need to understand the application. They need to be able to properly spider the application to understand what the attack surface is so that they can fuzz and exercise that attack surface to get good results back. The problems that we see with security tools, if you're a developer, is, again, I mentioned this before, developers don't speak PDF, right? If you go, and we see this pattern over and over again, security comes in, runs a scan, generates a 300-page PDF, the color graph on the front page, hands it to the development team and says, "I did my job, it's your, fix it," right? Apparently you guys are bad at software because, we got a 300-page report and the graph's in color. And there's a lot of red on the graph, which, and so you guys need to go for it. The even worse, what we see is organizations where they run two different scanners, right? Hey, we went in and ran this scanner, we ran this scanner. Now we have two 300-page PDF reports with two color graphs on the front page, right? 600 total pages of results, and it's, well, hey, some of these are probably repeated, but we're not sure which ones, right? And the challenge there is that gives the development team every excuse in the world to push back and say, like, you are actively wasting my time, right? I'm going to go to my VP, who we've made promises to for important customers. I'm going to go to my VP, and guess what? Security is no longer going to be a priority for this organization. And so that's a really big challenge. So developers don't speak PDF. For the security teams that have been nice enough to correlate all this stuff manually in an Excel spreadsheet, I'm sorry to let you know that despite, they're probably selling a Rosetta Stone for it, but developers still don't speak Excel either, right? And so trying to communicate with developers, we found that to be universally ineffective. And in a lot of cases, taking action for developers on dynamic scan results can be challenging, right? If you say, well, hey, you've got a cross-site scripting vulnerability on, if this URL for this parameter, in some environments, in like a kind of basic, PHP or classic ASP environment, okay, well, the name of the URL matches pretty well with the name of the file, right? And so that may be relatively easy to track down unless you've got some different things that are included or something like that. Right, but in modern web development frameworks, your login.jsp page might not be in login.jsp. It might be in com.whatever.login controller if you're using something like Spring. And so in a lot of cases, it can be challenging for developers to take action based on these dynamic scan results. And again, looking across, so taking a step back and looking at this, the developers have a lot of stuff to get done. They've got security fixes that you want them to get done, and features and other things that other people ask them to get done. From a security person, if you want to see them take action, you have to take excuses off of their plate. You have to reduce the friction in the process. And in doing so, what we've found in environments is that you start to get better activity from the developers. If you're working with them in the tools they're working in, if you're speaking their language, you're taking friction out of the process, and you're going to see developers start to make a lot more progress in on security tasks. So how do we make this better? Well, developers certainly need to know more about security. They need to learn more about security. You're not going to make every developer into an expert, but every developer should have some background, authentication, authorization. Why do I do input validation? How do I do contextual encoding? What are the libraries we use to conquer these different tasks? And so, that's certainly the case. But again, it's unrealistic, I think, for security teams to expect every developer to be an expert in things like this. Similarly, security teams need to learn more about development, right? This, like generating a scan, saying, well, I used to use Nessus to run scans against the network, and that gave me this that a PDF that I took around, saying now I'm running an XYZ scanner, that gives me a PDF. That's not going to be, again, that's a message that's not received well by developers. And so security teams need to learn more about how development teams work. Because, again, what you want to be able to do is go and speak to the developers in their language, and that's going to get you better compliance. You're going to be more effective in getting developers to take action if you can, if you can speak to them in their language and work with them in the tools that they're using. So what? The genesis of this presentation was some research that we did with the U.S. Department of Homeland Security, and we basically they had asked for solicitation. They said, here's areas that we want people to do research in. Make a proposal, and and we'll respond and possibly give you some funding. And what we were looking to do is to better integrate not security and development tools, but to make security tools work better together. And most specifically, we wanted to make dynamic scanning tools and static scanning tools work better together. We saw a lot of organizations where they were doing static analysis, they were doing dynamic analysis, in a lot of cases with tools from different vendors. And the result was we've got this PDF and this PDF, and if I want the data to work together, I have to take all these results from static and all these results from dynamic and dump them into an Excel spreadsheet and spend like way too much time trying to stitch this stuff together. And so, what we originally set out, like our phase 1 goal of this research, was to determine if it was feasible to take the results of a Fortify scan and an AppScan scan, dynamic scan, and stitch them together. And so, from a dynamic security testing standpoint, how do most of the dynamic scanners work? They, first have to figure out, like, what is the attack surface of this application that I'm going to be looking at, so that I can then move on to the next step, which is to fuzz that and look at the request and response patterns to determine if it looks like if I send this request and I get this response, that's indicative of a cross-site scripting vulnerability, or that's indicative of a SQL injection vulnerability. Everybody here's familiar with dynamic scanning tools, hopefully. Everybody? Similar in the static scanning tools, they look at application source code or an application binary, build some sort of data structure that represents how the application, how the application is structured, how it's supposed to work, and much like a compiler or virtual machine would, and then they perform some sort of different types of analysis in order to determine what if there are patterns that would be indicative of certain vulnerabilities or weaknesses. And so here we can see. Right, we get parameter, returns dirty or tainted data, that goes in username. That username gets appended into this string SQL, which is then also tainted. That gets fed to execute, and so that by being able to draw a line between this tainted input and this sensitive sync function, the static analysis tool is able to say like, oh, okay, well this is indicative. This pattern is indicative of a SQL injection vulnerability. And so these are different types of analysis. One of them is looking at the software in at rest and applying pattern matching to the structure of the software to try and determine if there are issues. The other is exercising a running application with no knowledge or little or no knowledge of how that application is structured. So it's a black box. I send this in, I get this out. So our goals for this research were to figure out can we standardize vulnerability types across these two different types of tools? Can we find a way to match the location, right, of if I have a certain request and response pattern, can I determine in the software where that request hits and where that response comes from? And can we figure out more about what the specific entry point to the software that is causing the problem? Can we identify those particular entry points? And so drilling into this, we basically needed to create some data structures in order to do this, and create a model, and then run some tests to determine if this were possible. We built this on top of an application that an open source application we put together called ThreadFix. And what ThreadFix is, it's an open source platform for application vulnerability management that lets you basically load in the results of different static and dynamic testing, both automated and manual, normalize and deduplicate the results, and then manage those through the resolution process. And I'll show some quick demos of that. But this was a good base for what we were looking to do, because we could already do dynamic to dynamic matching, right? You could load in the results of a W3F and a ZAP and an AppScan, and and ThreadFix will take those in, normalize the data, and give you one single view into those vulnerabilities. Similarly, we could do it on the static side, where you could load in the results of like a Fortify, an ounce or whatever. Again, it would normalize and then dedupe that data. And so it made sense to include this technology on top of that, so that we could take the static results and the dynamic results and stitch those together as well. That's a picture. That's a list of the different tools we can talk to. That's a slightly more fun page with pictures on it that basically says the same thing. And so in doing this research, we had to figure out, like, what do we consider to be a unique vulnerability? And in the dynamic, for dynamic results, basically we decided on the MITRE's CWE, their common weakness enumeration, as as our taxonomy for vulnerability types. And for dynamic results, what we found was, for certain types of vulnerabilities, just matching the CWE and the relative URL it was sufficient to indicate a unique vulnerability. And so, if you have a predictable resource location, if you have like login.php.back on the server, that's indicating probably some bad configuration management. It's easy to guess that this thing is here. It's probably not supposed to be here. And if two different scanners find that CWE with that same URL, again, probably the same issue. Same thing with like directory listings for misconfiguration, other stuff like that. If you're looking at injection flaws, things including like SQL injection, cross-site scripting, all of those injection flaws, then a unique vulnerability, according to our data structure, is that CWE. What type of vulnerability is it? What's the relative URL? But also, what's the injection point? And so, what's the name of the parameter that gets passed in and is being mishandled? Or what is the name of the the cookie or the header that you're sending in? Again, so by taking the results of these different scanners and normalizing to that, we're able to take different scan results on the dynamic side, load them in, and and end up with a consolidated list of those vulnerabilities. We picked the MITRE CWE. There's like every vendor has their own taxonomy that they use for keeping for describing how vulnerabilities are. We originally tried to create our own, which was probably misguided, and ended up working with settling on the CWE. It's funny when talking to the MITRE guys, or I like to say that the CWE is the worst vulnerability taxonomy out there, except for all the other ones. Right? It's like the democracy of vulnerability taxonomies. So CWE is exhaustive. It's a little sprawling at times, but it's a reasonably well-adopted standard. A lot of tools already had the mappings that we needed there. And so again, we found it to be a pretty workable solution, and certainly one that is better. It makes life a lot easier to use something like the CWE versus trying to maintain something like our own thing that we made up. It also helps us integrate with again, as we communicate this data, or if we need to normalize across different organizations, it makes it easier to do that. So with our research, what we did is we passed in to the technology, the engine we built, some amount of source code, either via being able to pull it from Git or from a local file path. Git usually works better because ThreadFix is a server-based application, so it needs to be able to get to the software. So like a relative file path from the server is a hard thing to set up via a browser. That's kind of a weird concept to set up. It's easier just to say, like, here's our Git repository, this is the branch that we're on, and here's the username and password, so they can get access to that. We also pass in or automatically detect the framework type. Right now, the technologies we support for this hybrid analysis mapping and the associated tools are Java-based. Java, JSP, and Java Spring applications are supported. We're working right now on ASP.NET MVC, and we'll have Visual Studio and associated plugins coming out soon. And then, in this case, because we were looking specifically at matching Fortify and AppScan results, we went to see if we could pull some additional information from Fortify as well. So for the vulnerability types, Again, we basically standardize everything back to the CWE. And we did some looking at software fault patterns. I don't know, for folks that are familiar with the MITRE CWE, they've got some associated vulnerabilities. We tried looking at matching across those. That wasn't really effective. But again, so what we do is we map everything back to the CWE, and we create a unified endpoint database. And so we do this lightweight static analysis of the application, where we run over the source code, detect the framework type, and we build a database where we basically calculate the attack surface of the application. And so we look across the code and take evidence from the code where we say this URL, like this application is going to expose the URL login.jsp. And the reason I know that this application is going to expose login.jsp and a username parameter is because I found a get parameter call in the file login.jsp, or because I found a call to, in a Spring situation, I found a reference to a model element in com.xyz.login controller, right? And so we build this database where we say, I think I'm going to have this piece of attack surface in the application, and that's based on this line of source code. So we go through the code, build this database, and then then we're in a situation where we can query that database and say, hey, I've got something here on the attack surface. Tell me what source code is responsible for that. Or you can go the other way and say, for this piece of source code, where can I expect this code to be attached to the dynamic running application? And in doing that, that let us do the static to dynamic matching, because we could basically say, well, I've got my dynamic scan results, again, that says I have a SQL injection vulnerability at login.jsp for the username parameter, right? On the static side, we could say I've got a SQL injection vulnerability, and the source function is at com.xyz.login controller line 93. All right, when we run those against one another, we say, okay, well, I've got this SQL injection on the dynamic side on the attack surface, matches up with the SQL injection in the code at this location. These are probably representations of the same vulnerability, so this request goes into the code here and comes out there. And so we can do that and match and consolidate. So that we were successful in doing what we wanted to do, which was to figure out, like, can we massage or can we manage this data such that we can link up static and dynamic results. The cool thing that came out of that, so we're sitting in a meeting and we're talking about how this is laid out and figuring out, like, okay, we're getting X percentage of matching. And then the question was, well, wait a minute. If we just queried this database, right, and said essentially like a select star from this endpoint database that we had, won't that tell us the entire attack surface of the application, right, independent of whether or not there's a vulnerability at those, at those points in the attack surface? So even before we've done the dynamic analysis, since we have this model, can we build an attack surface model of the application? The answer was, sure, we can just write another function to pull that data out. And similarly, we asked, well, even if we haven't done the static analysis, if we have these dynamic results, can we determine what the line of source code that the developer needs to look at is? And the answer was yes. And so coming out of that, what we figured is we can do some interesting things beyond what we originally looked to do. Just to talk a little bit about the technology under the hood, basically to parse the attack surface locations, in a JSP environment, we start through a JSP folder, and figure out the different files and files that get included. It's fairly straightforward. You've got to watch for some infinite recursion stuff and whatnot, but basically, those are just files laid out. The structure of, the structure of the site from a dynamic URLs that are exposed from that standpoint matches pretty similarly to what the directory and file structure looks like. In a Spring environment, this is more complicated, but basically what we do is we go through and we parse all the @controller classes to determine all of the attack surface, all the URLs that get exposed and whether they're get or post, or whether they listen to gets or posts. And then we parse the model classes to determine what parameters can be passed in. Similarly, in a JSP environment, we look for calls to get parameter right now, and we do some lightweight data flow analysis to see what gets passed in there. And in Spring, we parse the request params, path variables, and entity annotations. And so in doing this, we get this bridge that we use again to do this static to dynamic mapping. And so the question that we asked from this was, if I know the attack surface of an application, can I feed that back to a scanner to kickstart the spidering process, right? And this goes back to the story about like, hey, I ran a scan and in my 500-page application we scanned 2 pages, right? And so it's a question of, can I, like, if I know about the application's attack surface, can I seed the scanner with that information so that we get more thorough scanning? And the answer is, as long as the scanner has the ability to customize in that way, yes, you can, right? And so in calculating this attack surface model, we can feed that data to a scanner so that it knows what, it knows all the URLs it should be able to get to. And so that spidering process that the scanner goes through, where it says, okay, I'm going to start with the home page. Let me find all the links on the home page, right? I'm going to go to each of those pages and look for the links or forms that go off of there. Again, the scanner is probably still going to want to do that process, but you can seed it and essentially say, based on our model, here's every URL that this application should respond to, and every parameter that you should be able to feed to this application and get some sort of behavior change from the application. And so using this data, again, we can make the scanners smarter so that they can so that you can get better scan results, or your starting point is not trying to guess what parts of the application are there. You already know, or the scanner already knows what application stuff should be responding, and so you can get a more thorough scan. Similarly, if we go the other way, even if you haven't done a full-blown security static analysis, if I've got dynamic analysis results and a model that takes that takes each attack surface location and maps it to code, if I know that I have a SQL injection at a certain attack surface location, I can get the line of code responsible, not necessarily for the entire vulnerability, but I can get the entry point. And so what we figured is we can also go and make plugins for IDEs that take the results of a dynamic scan and map that back to the line of code. So in the static analysis world, all the static analysis tools have IDE plugins. At least most of them do, which is great, right? Because that's helpful for developers to say, right, I'm going to tell you that there's a problem, and I'm going to show you exactly where that's at, right? Which is a nice thing to do for developers if you want them to take action. In the dynamic analysis world, I don't know of anybody else that's doing that right now, where they can say, here's a dynamic scan result, and by the way, developer, here is where you need to go to start, to start trying to solve this problem. So based on this, we saw opportunities both to make the security scanning tools more thorough, as well as to put better information in the hands of developers so that they can do remediation more quickly. The basic system setup, we've got the ThreadFix server that has access to the application source code. We've got I'll show an example of working with the ZAP scanner. And so you can ThreadFix basically pulls the source code, builds the model, feeds it to the ZAP scanner that it then uses to inform its scanning of the target application. Those results get fed back into ThreadFix, and that data then with the lines of code and the vulnerability data, we can then send to an Eclipse IDE. Any questions about this? I want to launch into some demos, but I want to see if anybody had any questions about what we've done, or what we've talked about so far. Anybody? All right. Excellent. Yeah. Right now, we've got plugins written for ZAP and Burp, and we're looking at adding support to AppScan next. And with the data that we have, like a lot of scanners will let you feed them like a file, like a flat file. And so we've got a command line client that'll show you that you could probably run the command line client, fooey around with the results a little bit and get a file that you could upload to something. And so.
Every scanner basically needs other type of data. It's not a common format.
Yeah, it's not a common format, but that's something we've seen some interest in, and I had a chance to talk to, I don't know if Simon's in here, Simon from Zap, talked to Farah from Mabatuna. I've talked to a couple of the scanner vendors, and I think that there's interest in having a standard data format for this. I talked to the folks at MITRE. I was talking to some folks at MITRE and some of their government clients a couple weeks ago, and I think there's some strong interest there in that. The OWASP DEF project, or Data Exchange Format project, that Tom Stage is kind of picked up the ball and is working on lately. So I think there's some interest in that. There's not yet a standard, but the nice thing is if someone wants a standard, we have, basically this data gets fed, in our environment, These ThreadFix just has a REST API that the scanner calls into and says, feed me the endpoints, and it feeds the endpoints via like a JSON response. And so if somebody wants a standard format, I have a reference implementation of something that works. That obviously if they're, as we build out the model and make it more elaborate, I think that's going to need to change. But we've at least got something that we've demonstrated work for this type of a use case. That we're happy to change it to something else if somebody has a better idea, or in the absence of a better idea, we've got a thing that works right now. Yeah. A very lightweight static source code analysis. And so it's not, and I'll show you, we've got a command line client, and I'll show you how quickly the command line client runs. That'll hopefully give you an idea of just how like deep the analysis is. But we can also, some of the static analysis tools package, like in their results package chunks of source code. We can also like take that source code and build a partial model based on that. The matching works a lot better if you have access to the full source code.
In my company, our developers, they use Java. They use checksum, check the code, they code nicely everything. They use Finder, they use CMD. And then they use one tool, Sonar, SonarQube, to aggregate all those reports. Now, they complain, of course, it's too slow.
Right. This, even compared to like a FindBugs, this runs much more quickly than that. It basically runs through, because like FindBugs and PMD or one case, and if you look at even a more significant case where you have like a full-blown like data flow analysis from like a commercial static analysis tool, it takes even longer. This static analysis basically just runs through the file, tokenizes it, and looks for very specific chunks of text. And so it has the advantage of it runs very quickly, and you don't need to do a lot of configuration. You just point it there and it figures out and does the best it can. The disadvantage is you're not going to get the type of deeper insight that you would get from a commercial static analysis tool or even like a FindBugs or something like that. And so, again, like we run over a couple 10,000 lines of code in a second or two. I mean, it's the runtime has been negligible in anything we've fed to it so far for the depth of static analysis that we're doing, which again is pretty surface level.
Is it easy to extend to GSF, for example?
Yeah, and so let's run through real quick just to give you an idea. So the support that we have, the platform support for JSP is about 698 lines of code, of Java code. And the about just under 1,500 for Spring. And so it's not something that you could, it takes some time to go in and write the parser for the framework to get this, but it's not, it's not ridiculous. And so we're right now working on ASP.NET MVC, and we've got a little bit of work done toward Python Django. But it's certainly something, and we've talked to, I've talked to a couple people about the JSR 168, the portlet things and stuff like that. So I think there's some interest, and if folks are interested in extending this stuff, we're happy to support them in doing that. Basically you have to implement this endpoint generator interface that emits these those matching pair of here's an endpoint and here's the source code responsible for it. And so it's been designed in such a way that if your organization has like a custom framework that we see in a lot of places, again, it's a little bit of a development project to add in support, but as long as there's an algorithmic way that you can take source code and say this source code is going to look like this when it hits the server, it's something that can be extended. Okay, so just to run through, here. Basically, so this is ThreadFix. You can log in. See this here. And what we see here is, look at the different cross-site scripting vulnerabilities. And so here we see cross-site scripting vulnerability that was identified both by AppScan and by Fortify, where to the dynamic scanner, it was in the relative path /budget /contact.jsp. In the source code, it was in root/contact.jsp. We normalized that URL path, match the parameters, and then we can say, these two scanners found this, and we're able to roll this result up into one. Another interesting thing that we see, because we have a model of the application that we've built, we can further clean up some of the data that we see from these different scanners. And so here's an example. What you see in a lot of cases with dynamic scanners is they don't have an understanding of how the source code is structured. And so what you see with applications that may have like a RESTful style of URL creation, we'll have a vulnerability that's pet clinic owners /5/edit, owners /6, owners /7. Right? If a human looks at that, you say, well, that's not 3 different vulnerabilities, like this is all mapping to the same code. The scanners don't know that, but because of the way that we build that attack surface model, the hybrid analysis mapping knows we've got /owners, the next part is an ID, and then /edit is the thing that comes after that. And we know, like the model knows that all that maps back to the same line of code. Right? And so we're able to take these 3 vulnerabilities that were identified by AppScan and basically make a pass over those and consolidate it. And so that's another way that this type of knowledge, like if you take this knowledge of the application structure and pass the data from these scanners through it, what you end up with is a cleaned up data set, so that instead of developers saying like, hey, you've got 3 problems that you need to go fix here, you can instead tell the developers you've got 1 problem that you need to go fix here, and you need to go fix it at the code that is responsible for that piece of the attack surface. And again, from this, and we've got this is just a simple, we basically took the tech, and that's totally impossible for anybody to read, I suspect. That's not any better. Okay, so that was basically we just ran and built the attack surface model for the Java Pet Clinic, which is a pretty small application. But again, if you look at the speed that went through, it's not, that's not process bound. But see, what we see here is that we've been able to figure out that like this URL /owners ID pets ID edit, you can either post or put to that URL. Oh, that's weird. Oops. And below it are all the parameters that can be passed in based on the model. Also looking at this, when I look at a Spring application, we're parsing the model and looking at the auto binding configuration. And so I also look at this and say, this auto binding is configured to allow pretty deep binding, which is not necessarily a best practice. And so as a manual pen tester or as a manual code reviewer, seeing that this is how this is the parts, or this is the type of auto binding to be done, makes me think that there may be additional problems with that. But basically, this is just a command line tool that generates that attack surface model. And again, from a processing power requirement standpoint, that ran pretty quickly. Or we can go. All right. Oops. What did I do here? Hello. This is very bizarre. Of all the problems I've ever had with demos, losing control of the mouse is not something that I've ever had trouble. There we go. All right. And so here what we can see, or what we can do, is clear out our Zap session. But we've got a plugin that we've released for Zap that basically lets us go and import these endpoints. So we connect to the ThreadFix server. We tell it the application we want to pull the data for. Give it the base URL. And it pulls in those endpoints. And so what we see here is that we've found pages that we would not have otherwise found, like this admin page, this admin.jsp page. If you crawl the application, you're not going to find that. There's no links to admin.jsp in the application, but the application exposes that page. Similarly, if you look at a number of these debug parameters, if you crawl the application, you're never going to find a reference to those debug parameters, right? Because it's not, it's a debug functionality. It's not supposed to be there. But if you pass in that debug parameter, the application is going to do something based on it. We did some work on a Cold Fusion application where any page in the application, if you pass in a parameter named D, it would take the value of that parameter and try to delete the order with that number. So if you passed in D equals 1,000, it would try to delete order 1,000. Right? Like, I don't know why the application did that. I think it was like a convenience feature, right? Some sort of administrative convenience feature that had somehow gotten cut and pasted into every page in the application. But again, this will help to identify situations like that so that you're exposing those parts of the application to to fuzzing. And again, what we're going to get here is a much more thorough scan of the application because we're getting all the URLs. And so if you have landing pages in your application that maybe link back into the application but nothing links back out to them, again, if you have this hidden debug functionality, if you've got auto binding turned on, this is going to let the application scanner know here are additional pages you need to look at and here are additional parameters that you need to fuzz if you want to get thorough testing of everything there. And yeah, that's the icon I need. There we go. And similarly, what we can do is connect to ThreadFix and pull data about the endpoints. And even with just a dynamic scan, we map back to lines of code, and so we can put these markers. We can put these markers in the line of code. Again, with the full static analysis results, you're going to get better. You're going to have a better user experience if you can show the entire data flow and control flow. But at the very least, with the dynamic scan results sitting on top of this hybrid analysis mapping model, that lets you map back to individual lines in the IDE, which gives the development team a head start. And so the idea here is, how do we put developers in the best position possible to fix, these different vulnerabilities? There we go. Let's see. Okay. Any questions about those integrations? And so right now we support on the scanner side we support Burp and Zap with plugins, and on the IDE side we support Eclipse and IntelliJ. We're working on support for ASP.NET MVC, and out of that we'll also be building a Visual Studio plugin as well. And again, just looking at the relative level of effort to construct those the parsers for the different frameworks. It's something that takes a couple of days, to kind of get something first working, and then you refine that with additional testing data from there. So what's next? We actually started a phase 2 with the Homeland Security folks, which is great. So that's allowing us to add support for additional frameworks like ASP.NET. We're looking. We've done a little bit of work with Python, Django. We're looking to add struts, JSF, or Ruby on Rails, and working on Visual Studio. Another thing that we're doing that I think is pretty exciting is we're going to expand the model, the attack surface model that we're building. And we're going to add concepts of authentication. Which pages do you have to be authenticated for versus not? We're going to add the concepts of authorization. For these pages, you need to be in this role. And we're going to also build out additional injection points. Right now, we're only considering get and post parameters as well as path parameters in REST-style URLs. We're going to be adding cookies and other HTTP header injection as well. And what I think that's going to let us do some really interesting stuff where, based on that model, if you have a static scan result that says, I found 1,000 cross-site scripting vulnerabilities in your application, if you also have a filter where that you can apply to say, but these URLs are the ones that you can get to when you're unauthenticated. That allows you to start to triage data more quickly by saying, I've got 1,000 results that I'm worried about, or I've got 1,000 results, but only 100 of them can be accessed from an unauthenticated user. Therefore, I'm going to focus on remediating these 100 first because these are the ones that I consider to be higher risk. And so, again, I think there's some pretty cool analysis that you can start to do if you've got a structured model for what an application looks like. What's the attack surface? What are the injection points? Which portions require authentication or certain types of authorization? Because from that, you can start to make decisions. And that's, again, a big push that we've seen in a lot of organizations that try to scale is, how can we better manage this giant volume of data that we've got? I think I'm just about out of time here. But again, this is stuff you can download from GitHub. And feel free to reach out to me if you've got any questions. If you want to add support for something, let me know. And I don't know, do we have time for questions now? Or are we done? Done. So I will be around outside. If you have any questions, please feel free to track me down. Thank you all very much.